Okay, so the solution to this question. So the first thing we're told is that the numbers 4 and 9 have an odd number of factors. So factors are numbers that divide evenly into other numbers. And so what are the numbers that divide evenly into 4? Well, the number 1 divides evenly into 4, the number 2 divides evenly into 4, and the number 4 divides evenly into 4. What are the factors that divide evenly into 9? Well, we have 1, we have 3, and we have 9. Now, just before we move on to the next part of the question, most numbers have an even number of factors. Take a number like 10, where we could say that that's 2 by 5 and 1 by 10. We can see that there's 4 factors in 10, an even number of factors. A number like 24, we know that that's 24 by 1, 12 by 2, 6 by 4, 8 by 3. That has 8 factors, which is an even number of factors. And so the second part of the question then asks us to write down the next 3 natural numbers, so whole positive numbers, which have an odd number of factors. And you have to kind of observe something about this. And this isn't something necessarily you would have learned off by heart in the course. It's just something that they want you to kind of spot, having seen the factors of 4 and 9. So what would have to happen to have an odd number of factors is that one of the numbers would have to multiply by itself. So 1 by 4 is obviously 4, but then what does 2 multiply by? 2 by 2, and you don't write down 2 twice, so that's 2 squared. What about 9? Well, 1 by 9 is obviously 9, but what else multiplies by 9? 3 by 3, or 3 squared. So it seems to me to have an odd number of factors, you have to be what's called a square number. So 4 is 2 squared, so 2 squared is 4. 3 squared is 9. Well, what's the next number then that must have an odd number of factors? Well, I would imagine 4 squared, which is 16. So let's test 16. The factors of 16 are 1 by 16, 8 by 2, and then 4 by 4, which is 1, 2, 3, 4, 5 factors, which is odd. So if you are a square number, you have an odd number of factors. So the next 3 natural numbers are 4 squared, which is 16, 5 squared, which is 25, and 6 squared, which is 36. And so the answers to the B part of the question are 16, 25, and 36 are the next 3 natural numbers that have an odd number of factors. And if you want to write in the side margin, again, you're looking to complete the papers here and have them as neat as possible, I would write down that square numbers have an odd number of factors. Now, why is that again? Well, because one of the numbers is squared, for example, 2 squared, 3 squared, 4 squared, to give the actual number. And so that's why it won't be in a pair with a different factor, because it's been multiplied by itself. Again, not something you'd learn off by heart on the Junior Cert higher level course, but something that's apparent as you go through this question if you're able to answer it. Okay, what's the pattern of these numbers? So again, on the side of the page, just writing a few little notes. So linear patterns, remember, the types of patterns are where the gaps are even. 2, 4, 6, 8, 10. So it's going up by 2 each time. We say that the first difference is the same if it's linear. A quadratic pattern is where the second difference is the same. So let's have a look and see, is the first difference the same, which would make it linear, or the second difference, which would make it quadratic? Or is neither of those things true, in which case it'll be a totally different type of pattern. So what's the pattern of these numbers? Well, we have 4, we have 9, then the next 3 we wrote down were 16, 25, and 36. So let's look at the gap between each of them. So I'm just going to get a different color pen here. So difference between 4 and 9 is 5. Difference between 9 and 16 is 7. 16 and 25 is 9. 25 and 36 is 11. So clearly the first difference isn't the same. These numbers are not linear. So are they quadratic? So the second difference, is the second difference the same? Well, let's go and see. What's the difference between 5 and 7? 2. 7 and 9? 2. 9 and 11? 2. The second difference is the same, and so this is a quadratic sequence or quadratic pattern, and that is the answer to the question. Okay, what about part D? Use this pattern to write down a number between 101 and 200 which has an odd number of factors. So what we're looking for is a square number between 101 and 200. So hopefully people know a few square numbers between 101 and 200. 10 squared is 100, so obviously 100 isn't going to work. Well, what's 11 squared? 11 squared is 121. That's a possible answer. It just asks you to write down a number. So you only have to do one. So 121 is my answer. What else could I have had? I could have had 12 squared, which is 144, which has an odd number of factors. 13 squared is 169. 14 squared is 196, and there won't be any more square numbers. So any of these four answers would be okay for this question. So that was question 1, and we saw factors, we saw square numbers, and we saw quadratic patterns. And I would just make sure that you write that in a different color pen somewhere on the page, just to highlight. If you want to come back and revise any of those topics, this is a good question maybe to have a look at.